Hello and welcome everyone. It's 7th day of our 5-day stream series about a testing library for scheme language. Today we will focus on writing tests for the library using the library itself. The primary reason for writing tests here will be, first of all, kind of documentation, showing the capabilities of the library and the usage scenarios. The second one is giving us some confidence when we change the library. We will be sure that interface we documented and written in tests in this file is not broken. So those two are primary reasons. Maybe there's some other reasons that we will figure out during today's stream. I'm Andrew Tropin. I work on operating systems and programming languages and do a lot of free and open source software along the way. Let's get to our tests. We already have some tests written in the library itself, and we will slowly move them from the library to a separate file to make sure that the test code is not affecting our final library and is not present when we distribute it. Because in runtime of during the usage of our library, the tests are not needed. They needed only when we preparing a release or something like this. The first obvious candidate for testing will be is macro, because it's a basic assertion macro and we will use it all over the place in all the tests we write. I have a few use cases in mind and I already started to write them down. The first one is the basic atomic values which we can pass to the is assertion. In addition to that, it can be a variable which returns basic atomic values, which should work the same. We can test it out in a separate test case, like this. Let's say we have kind of strange alignment. I guess in dir locals el. I don't know what those numbers means. It's like completely obscure. Let's see what we have in geeks dir locals. Yeah, it's completely unclear what those numbers mean. Okay. Oh, now it's aligned, but why the heck it has like two spaces here? Is it right? I'm not sure. I don't want to have two spaces here. If something, when something. Okay, it seems the alignment is similar to when. Okay. it's fine. An expression asserting atomic value of the variable. Predicates. Predicates are kind of obvious. We have an expression, and the first argument of the expression is some kind of predicate. We wrote a couple tests for this one. The next one is a bit trickier. It's about nested is and is return value. We expect that our whoa. That's interesting. Line 41. I have some pseudocode here and some comments. Okay, we expect that our is macro returning a value of the expression. Wrong argument, expecting atomic box got false. Okay. That's because we set current test runner to false. Okay, about is. Okay, let's go back to our library and let's evaluate everything here, and let's try to run the assertion. Okay, it works. It works. Okay, we can see the last modification we did for the library made it return a summary, a test summary on each run, which is useful, but our expectation that assert macro always return the value it has here. Let's say plus 3, 4 equal to 7. But sometimes our is macro returns the summary, and sometimes it returns the value, and it depends on if our most outer form, if is our most outer form or not. As you can see, the nested is returns the value of the expression, and the outer is returns a test runner summary. I think we always want to return the value, and the funny thing that those tests are actually for test runners, because the test runners has most of the logic baked in and the semantics, and is and test case and test suite macro are quite thin wrappers around test runners. And here we can write those tests and execute them with different test runners. And to verify it, we need a very simple test runner that we are sure to work properly. So ideally we need to implement the simplest test runner, which so simple that it doesn't contain any errors. Get silent test runner is quite simple. Get silent test runner looks good to me. Okay, let's do the following. First of all, let's start making pages. And for those pages we will write a simple description what they contains. Tests for is, test case, test suite that we can use to test runners. It's a lot of test words in this description. I have some comments and like thoughts over here. Let's cut them for now, and let's commit the file. File suitbl test suitbl basic tests. Now let's return back those thoughts as a comment here. I guess we can start steadily moving the comments and design thoughts from the library itself to the tests. And actually those comments are not up to date anymore. Okay. First thing that I still not sure about is the naming convention. Here I use a test suite prefix for each test suite, but do we really need it? Is usage. Test case usage, and of course we need a test suite usage. Test suite usage. Do we need xfail xpass? There's some thoughts on the design of the library, and more precisely we were discussing the test case results. It can be pass, fail, error, skip. It could be xfail and xpass for expected failure and unexpected pass. But the cool thing that we can actually implement it on a test runner side. So our infrastructure will remain the same. We will have test cases, test suites, and is macro, and the test runner will handle different test case results other than those default ones. But we can do it later, of course. Implement the test runner that provides xfail and xpass functionality for some workflows. For example, using this feature, we can send a patch which implements test, which reproduces some bug that we don't know how to solve yet. And we can put it as expected to fail test and come back to it from time to time. And at some point, when somebody fixed this bug, this test will become green, and it will be unexpected pass, and we will just change it to the usual test, which is not expected to fail, but expected to pass. This is a use case for xfail and xpass. It's still like unclear how needed this feature, but the design of our library should allow to implement it via custom test runner. Okay, let's go to the test case usage. this test will fail. I still don't know how we implement metadata, but we definitely need metadata at least for test suits to be able to control if we want to run the test cases of this test suite, which probably should be inherited by nested test suits. So our metadata of most outer test suite should be inherited by nested test suits and nested test cases, so we can decide if we want to run this particular test case or not. I don't know how we merge metadata, but it also can be implemented on the test runner side. And we can decide on test runner side. So for now, let's make a failing test case, and later we will figure out what to do with it. And also let's open our suitbl. Let's open oh, we even had this test here. We need couple more test runners, very simple test runners which will allow to set them temporarily to get just a result. Okay, what I'm talking about, let's see our silent test runner, right? Get silent test runner, define test runner. Let's say simple test runner. Very simple test runner. What this simple test runner does, it takes a message, case message, schedule test case, and it executes test case sunk, right? I'm still not sure if we need to wrap our is assert into test case on the test runner side or inside macro, because we will need to repeat it from one test runner into another test runner into another test runner. But I guess it should be like baked into the library. But on the other side, maybe somebody won't like those hierarchy that we built and would like to customize it. However, giving too much flexibility is also a bad thing, because people will tend not to use the library because it's too much flexible, it's too hard to implement something because you need to handle so much things. We need to find a balance here. Okay, Boom, boom, boom. I have IRC chat and YouTube chat open. So feel free to send some messages and comments and questions. And also, if you find something interesting about this stream, or you got some question, don't hesitate to contact me on Fediverse or email and share your thoughts. Would be very glad to read and reply. Okay, our simple test runner just returns the result of test case. We have default run assert. Simple test runner. We have default run assert, which test case events. Blah blah blah. Simple profile, blah blah blah. Let's remove this with exception handler. Let's remove this default report. Let's remove this error. Form sunk. Let's remove this and let's do this. Okay, and it will be a function here. Default run assert, simple run assert, simple run assert, simple run assert. All right. Let's, instead of anonymous, let's set the description to false for test case. And I guess we can factorize this thing and reuse it in different test runners. Message run assert function, and basically that's it. And here have message run assert function, run assert function. Takes message extract assert sunk quoted form and wrap them into test case if necessary. Call to like this. Message and simple run assert. Sounds good. And now let's try it out. Have simple test runner with, don't remember the name of the macro we implemented. Reset test environment. Get test runner. Test environment. Okay, lambda simple test runner. Define and get simple test runner. We need this wrapper because most of the test runner will contain some state, and we may need this state for gathering summary information or something like this. And in our simple test runner we just basically don't have this state. Else rise exception rise exception use message make Okay, not okay. It happened. And simple test. Get simple test runner. What else? I think it's enough. And now we can do okay, it's good, it's good. It's a good test case. Start test case and true. About this one, run scheduled test cases. Okay. Papam. Schedule test case. The simple test runner is intended to run assertions as soon as it found it. However, we have run scheduled test cases. We rewrote our macros like test case, test suite, and is macro. Oh, okay. Let me do the trick. Simple test runner. Instead of wrapping it into test case, right? I just do a simple our test runner won't be wrapping it into test case. It will just run the assertion. Okay. Oops. Message. Pam 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 pam. Boom. Run assert function. Simple run assert. Is 1 2 3 is error A. Error. Very nice. Very good. Result of is assert. We don't even need this simple test runner to be part of our library. I guess we need it only for tests. I just checking if there is a dot at the end of the sentence in the Emacs function docstrings. It's really hard to bootstrap a testing code for testing library. Okay, let's commit some changes. Also, let's reset environment. Export. Okay. Good. Now we can do the following thing. Yeah, basically we can run the following expression. That's right. But with this simple test runner, we kinda violate the rest of the library expectations. If we do a test case around this one and try to execute, we get the exception. Oh, whoa. guess we need S9 exceptions. What else? Okay. That's expected. That's expected. See what we can do. We know that this simple test runner is so simple that it can't fail. Right? So we can write a test which does the following trick. Reset test environment. Any other, let's say, how it's called, suitbl get default get test runner. I don't really like the name, but let's pretend it's okay. Let's do suitable default get test runner. And now we can check something. Is test case test is 1, 2, 3. Okay. And also what we can do is current I wanted to just set parameterize current to what? To what I would like to set it. Port, flash port. Okay, let's implement a function. Define ignore current output port sunk. Go with okay, lambda port, parameterize port, sunk. Okay. And maybe syntax. How it was named? Port stx. I guess I did something horrible. Return. Okay, let's do syntax case stx name why it returns empty line. Okay. Call with output string. Okay. I just want to create a port, a throwaway port like def null, in which I can put everything that I want. Scheme analog of def null. Very unhelpful results. Language, scheme language, port. Oh, thank you. Open output nowhere sounds like a perfect thing, but it is for Racket. Output. We actually can implement this open input nowhere, but we will do it in a more simple way. We will use open output string and we'll just ignore it. Nice, it works. And if we do display high, yay! What if the suitbl port because it's unbound, because we didn't export it. Test runner output port. Great. So we can implement the test for other test runners using this simple test runners. This way we bootstrapped our testing infrastructure of our testing library in terms of our testing library. And now we can implement a very simple CLI test runner to be able to run those tests, I guess. Popon. That's simple test runner for bootstrapping. Infrastructure. What we will do here, we can run a lot of different asserts, but also we can call a current test runner and ask him for test summary and check if this test summary contains some answers. And later we can return. Actually, probably we don't even need this simple test runner, because we can just like compare the result of this expression with our expected value and return 0 or 1, like exit code, to our CLI. Boom, boom, boom. Getting back to the question of naming test suits, you probably know that we can call test suite with something like this. Right? We also can do another trick. Val region. This is a symbol, and this symbol returns a function, and it can contain spaces. I guess the defined test suite should contain test suite name in the description. To make the interface of define, we can do define function name lambda blah blah blah. We can define suite name, don't know, is usage 2 suite Do we want to expose define test suite at all? Maybe not. On the other hand, it creates one more level of nestedness, like the usual define. And define test suite doesn't. Yeah, this simple test runner is a bit useless because we just basically wraps the execution of it into this construct, and we can do it without test runner. Okay, let's commit it. Okay, I guess simple test runner doesn't make sense without test cases implementation. So at least we need an implementation of scheduled test case. So we can have multiple asserts to check against. And funny thing is that we can't implement it like this. Because that means that our run scheduled test cases will return an exception or some arbitrary value not related to test case results. So we need to do the same thing as we did in our usual test runner. Where's our usual test runner? Default get test runner. Oh, it's here. Like we do. Where we do it? Here, default run assert. When we communicate using test case events variable. Also, of course, we need to re-implement the profiling, because right now it's just whoa, how we got here. Simple profile just go straight to test runner output port and print runtime. Which is okay in some cases, but we don't really want it. Okay, I think that our stream becomes a bit too silent and too slow, and probably not very informative for you, because I basically sit in front of computer and try to go through all the details and come up with some ideas. And also I'm a bit sick and tired at the moment, so it's not very efficient spend of my time and your time as well. So I guess we will sum up the stream. We did a bit of splitting between the primary library implementation and a separate model with tests. We moved some tests and wrote a few new ones, added a few wrappers and helpers here and there, exported some functions from libraries so they're accessible in our test model, and wrote some comments. We did it even before the stream during the discussion of library functionality, but it's still here. I guess I need to spend some time to write down those comments in more useful way, like to clean up and remove stale ideas from them and write down only up-to-date ideas. And also we need to clean up the library itself, because it already contains like 700 lines of code, and it contains some outdated documentation and probably some already unnecessary helpers and tests and comments that we also need to clean up. But we will do it later, maybe on the next stream, or maybe I will do it on my own before the next stream. Anyway, hello Yashvans M. You came to the last part of the stream where I summing up the things that we did and the things that we plan to do, and we're basically finishing the stream. Okay, thank you everyone for joining. I hope you enjoyed, and I will see you in a bit.